One of the questions I wanted to start with, have there been any major philosophical shifts in the curation of C++ as a language over time? And if so, what are the causes and consequences?
Probably the biggest shift was when generic programming moved from sub-paragraph of data abstraction to a primary topic. And to a large extent, it was seen from use, and it got the final push by Stefanov's STL. But that's probably the major thing. If you look at that one there, the first bullet was there from the start. The second bullet was there in the first couple of weeks. Object-oriented programming came a bit slowly because the people at Bell Labs didn't believe in virtual functions. Mm-hmm. They told me that if I don't know which function I'm calling, I've not done my analysis properly. And in the end, I had to decide that actually virtual functions were very important for very important application areas. So that one could be set there. I said generic programming definitely moved up in the priority order. Compile time programming, we started very early. One of the things that we needed virtual functions for was to run fast when we needed to select among alternatives. And before virtual functions, we had to use things like strings and hash codes and such. We moved all of that, or I moved all of that into the compiler so that we used indices to run fast. So that is one of the earliest compile time programming. Inlining was very essential. You couldn't afford abstractions unless you had inlining, now context for functions. Concurrency was there from very early on, and I don't think anybody liked the preprocessor, even back in the late 80s, not even the people who invented it. It was just the best they could do at the time.
One of the questions that was for me, but I'm going to do a judo move and redirect it to you, because it's your proposal, is what do you think of C++ profiles?
Oh, we need them badly. It's as simple as that. People want safety, and they don't quite know what safety is. Some people think they can get security out of memory safety, the absence of memory leaks or memory corruption. It's not that hard to get these things, the range checking and such. But in C++, it'll have to come from profiles, and it'll have to come without breaking a billion of lines of code and programming styles and techniques. I think profiles is the only way I know that can do that. And I did express a certain amount of sadness that we didn't already have it in next year. But you know, we may get implementations next year if we don't get a standard. It wouldn't be the first time that something arrived and was used seriously in production on a large scale before it got standardized, like, well, C++. That's very important. I think a lot of people, when they think philosophical shifts, people think, for instance, the ideals of safety are new. They were there from the beginning. Static type safety, resource safety, and some of the safety fanatics haven't even gotten to resource safety yet. And we can do much better, and I think we will. Evolution gets us from there to here, and it gets us further. I really want profiles up near the top there.
What is the best single piece of advice you have for junior developers looking to improve their C++ skills?
Don't try to understand everything. I guess these questions, I want to learn C++, I want to know everything. And then I give my answer to your question, and they come back and says, no, I want to know everything. But you can't know everything. A language is a whole lot of rules, and they're hard to implement. I believe there's not yet been a complete implementation of C, because some of the details are too obscure and difficult. You have to not lose the forest for the trees. You have to get an overview of the language. You have to decide which bits are important, and design an evolution of C++ is, if you are into philosophy of it, But a lot of new programmers, a lot of students have very little patience with philosophy. They just want to get rich. I teach students just about to go out into industry, and a lot of them really think they can be Bill Gates in 2 years. The tour of C++, if you're already a programmer, gives you again this framework for understanding the rest. I think some English philosopher in the 1600s says there's two kinds of knowledge, what you know and how to find. And that's, I think, pretty fundamental. I use cppreference.com a lot because I can't remember all of those function arguments and details. If I did, I would be a very worse programmer because I would be worrying about language details all the time. So look at the sort of the framework. Don't get obsessed with the details. Curse the debugging you have to do because, well, you have to. But don't think that's the whole thing. And don't get obsessed with one little fashion of how to write code, because there's so many application areas, there's so many different ways where importance are put. Like performance are essential in some areas, but in many areas they are not. Absolute safety is important in some areas, then you have to define safety. In some places they are not. You have to decide what's important.
I'd like to finish with two questions that are more general. They're not specific to C++, but taking advantage of your years of wisdom and in general career advice and general questions. How did you decide what to focus on throughout your career?
One is to work with good people and hang out with good people. That's nice. Sitting on your own is not fun, and working with jerks and having to protect your back is not good for your health. And so I've always looked out for how to be with interesting and good people. And usually interesting and good because they're doing interesting things. So you get inspired. So the other way of looking at it is I look for something interesting that is fun and useful to work at. I want to build something, I want to do something for people. And those two aspects are closely related. And at any one time, I can't say which one I'm doing. So I learned object-oriented programming by having a serious number of beers with Christian Nygaard, because he was a visitor to my university and I was a grad student. So I got into that. Similarly, I like machine architecture and design of machine instructions and such. That was just because somebody down the corridor was building a microprocessor. So basically, keep your eyes open, have a broad background so that you can take an opportunity when it walks by. Like Christian Nygaard, he had to go up the stairs to the guest apartment, literally. And so you have to know enough about languages and compilers to actually benefit from what he has to say. He didn't know compilers, by the way, but he knew languages and uses of languages. Similarly, I've done machine architecture, so I could pick up the interesting stuff about microprocessors, which actually happened to have come out of the lab in Cambridge from Maurice Wilks and Davis Wheeler. And so when I had done machine architecture, I certainly could get on with those people and learn from them. So what you do and how you get ready to do it. And a good, solid, broad education is what's underlying it. I think was some Frenchman said, fortune favors the prepared mind. Mm-hmm. That is, you have to recognize an opportunity when you see it.
So working with good people, interesting people, doing interesting things, working on interesting things, those are things that resonate with me as well.
And thing that that I mentioned briefly, and I should probably repeat. I like to do things that is useful to other people.
Yeah.
I don't want to do crossword puzzles.
I was going to joke, there's time enough for that when we're retired, but he has already failed to retire 4 times. You have retired 4 times, and you can't stay retired.
Oh,
so, congratulations.
Yeah, I'm not very good at that.
And that's not exaggerating, that's actually factually true. The other thing that I like to add to those kinds of questions, the good, interesting people, interesting problems, absolutely important. And you also touched on learning, the importance of a solid education, and that tweaks to me also the importance of being curious. Stay curious. We're always wanting to learn new things because our education isn't something we do and then stops. If somebody thinks that they've learned what they need to know and they stop, they will stop. They won't progress further. We're always learning. The world is changing. There's always more to learn. Just think about all the things in computing now and in the world now that did not exist, or we didn't even know about because it didn't exist as productized and at scale even 5 years ago. And to that, here's a final question, which is really difficult to answer, but it's a question for our immediate and long-term future. So it's worth to get a snapshot of thinking now. How do you say AI impacting software development practices to the extent that we can know that what we know so far in a very, very rapidly evolving field?
First of all, I'm not an AI expert, and I don't plan to become one. I've got too much work to do in other areas. So that's an area I cannot pick up. I don't have the background, I don't have the time, I don't have the people that could fire me up. So I'll never become that. I have some worries. And you know, I've always got some worries. I'm trying to solve problems, and to solve problems, you have to start worrying about something. But the thing that I see is that people are using LLMs to get answers. And there's lots of stuff about letting them do the simple things. And I worry that we lose the skill to determine what is good and what is correct, because we are not actually practicing doing things. We lose the ability to do it ourselves, and then we come to trust the AI, and the AI is, at least now, not trustworthy. And that is similar to when we started outsourcing and offshoring stuff because it was cheaper, and it worked beautifully for a couple of years until we lost the people who could actually do quality control on what was offshore. The skills were outsourced and such, and the companies that were doing it lost the ability to see what was good and bad, and then they got bloat from the outside. And I'm worrying that instead of being able to do fairly straightforward things, we then have piles upon piles and tools and cross-checks and double checks, try and avoid the faults of the AI. But it's so complicated. I will never become an expert on this.
Thank you for sharing your insights with us and for joining us here at our Accelerate offsite.
Okay, thank you. Thank you.